Conduits are not suitable locations for electrical splices because they do not provide adequate protection and accessibility for electrical connections. Splicing in a conduit can increase the risk of electrical failures, insulation damage, and fire hazards. The National Electrical Code, or NEC, sets standards for safe electrical installations, and these standards generally prohibit splicing conductors within conduits without the use of approved enclosures. These enclosures, commonly referred to as junction boxes or splice boxes, provide a contained and protected environment for making electrical connections. Firstly, the primary reason conduits are not designed for splices is the lack of space and accessibility. Conduits are intended to provide a pathway for conductors to run from one point to another. They are typically sized to accommodate the conductors themselves, along with a minimal amount of additional space for pulling the wires through. Attempting to make a splice within a conduit can result in overcrowding, making it difficult to properly insulate and secure the connections. Secondly, accessibility is crucial for inspecting and maintaining electrical connections. Splices need to be periodically checked to ensure they are tight, clean, and free from corrosion. If a splice is buried within a conduit, it becomes extremely difficult to access for inspection or repair. This lack of accessibility can lead to undetected problems that could eventually result in electrical failures or fire hazards. Thirdly, the NEC mandates the use of approved enclosures for all electrical splices. These enclosures are designed to protect the splices from physical damage, moisture, and other environmental factors that could compromise the integrity of the connections. The enclosures also provide a degree of fire protection by containing any potential arcing or sparking that may occur. Fourthly, splice boxes are specifically designed to provide a safe and accessible environment for making electrical connections. They are typically made of metal or plastic and come in a variety of sizes and shapes to accommodate different wiring configurations. Splice boxes have knockouts or other openings that allow conduits to be connected, providing a continuous raceway system. Fifthly, when making a splice in a conduit system, it is essential to install a splice box at the location where the splice is needed. The conductors should be brought into the box through the conduit openings, and the splice should be made inside the box using approved connectors or splicing methods. The box should then be securely closed and properly grounded to ensure electrical safety. Sixthly, the NEC specifies the requirements for splice boxes, including their construction, installation, and grounding. For example, NEC Section 314.27c addresses boxes that are mounted to a surface and must be designed so they are suitable for the conditions. It is important to consult the NEC and local electrical codes to ensure that all splice box installations comply with the applicable regulations. Seventhly, selecting the right size and type of splice box is crucial for ensuring a safe and reliable electrical connection. The box should be large enough to accommodate all of the conductors and connectors without overcrowding. It should also be suitable for the environment in which it will be installed. For example, in wet or damp locations, a weatherproof splice box should be used to protect the splices from moisture. Eighthly, it's important to consider the full capacity of the splice box. NEC Section 314.16 dictates how many conductors, devices, and fittings can be installed within a box based on its volume. Overfilling a box can lead to overheating and potential fire hazards. Ninthly, when working with electrical systems, always prioritize safety. To energize the circuit before making any splices or connections. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Tenthly, it is important to also consider the grounding and bonding requirements when installing splice boxes. All metal boxes must be properly grounded to provide a path for fault current to flow back to the source, reducing the risk of electric shock. Bonding jumpers may also be required to ensure electrical continuity between different metal components of the system. 11thly, when making splices inside the splice box, use only approved connectors or splicing methods. Wire nuts, crimp connectors, and terminal blocks are commonly used for splicing conductors. Be sure to select connectors that are appropriate for the size and type of conductors being spliced. 12thly, ensure that all splices are properly insulated to prevent short circuits and ground faults. Wrap the splices with electrical tape or use heat shrink tubing to provide a reliable insulation barrier. 13thly, when installing splice boxes in accessible locations, such as attics or crawl spaces, be sure to provide adequate clearance around the box for maintenance and inspection. The NEC specifies minimum working clearances around electrical equipment to ensure that workers can safely access and service the equipment. 14thly, regularly inspect splice boxes and electrical connections to identify any signs of damage, corrosion, or loose connections. Address any problems promptly to prevent electrical failures and fire hazards. 15thly, when adding or modifying electrical circuits, be sure to update the circuit directory or panel schedule to accurately reflect the changes. This will help to prevent confusion and ensure that the correct circuits are energized when performing maintenance or repairs. 16thly, the use of enclosures like splice boxes is important to prevent electrical faults from escalating into more dangerous situations. A well-protected splice minimizes the risk of arcs and sparks that could ignite surrounding materials. 17thly, remember that electrical codes are in place for a reason. They are designed to protect people and property from the hazards of electricity. Always follow the NEC and local electrical codes when working with electrical systems. 18thly, if you're unsure about any aspect of electrical work, it's always best to consult a qualified electrician. Electrical work can be dangerous, and it's important to have the knowledge and experience to do the job safely and correctly. 19thly, using the correct tools can greatly improve the safety and quality of your electrical work. Invest in a good quality wire stripper, crimper, and multimeter. These tools will help you make clean, secure connections and troubleshoot electrical problems. 20thly, when working with older wiring systems, be extra cautious. Older wiring may be deteriorated or damaged, and it may not be up to current safety standards. If you encounter any problems with older wiring, consult a qualified electrician. 21stly, if you are making splices in a hazardous location, such as a gasoline dispensing area or a chemical plant, you must use explosion-proof splice boxes and fittings. These boxes are designed to contain any internal explosions and prevent them from igniting the surrounding atmosphere. 22ndly, always maintain a neat and organized wiring system. Use cable ties or other means to secure the conductors and prevent them from becoming tangled or damaged. A well-organized wiring system is easier to troubleshoot and maintain. 23rdly, when running conduit, be sure to properly support it to prevent it from sagging or becoming damaged. Use conduit clamps or straps to secure the conduit to walls, ceilings, or other structural members. 24thly, when terminating conductors at a splice box, be sure to leave enough slack in the wires to allow for easy access and future modifications. The NEC requires a minimum of 6 inches of free conductor length at each outlet, junction, and switch point. 25thly, when working with aluminum conductors, be sure to use connectors and splicing methods that are specifically designed for aluminum. Aluminum conductors are more susceptible to corrosion than copper conductors, and special precautions must be taken to ensure a reliable connection. 26thly, regularly test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect people from electric shock by quickly interrupting the circuit when a ground fault is detected. 27thly, consider using surge protection devices, or SPDs, to protect your electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment and cause fires. 28thly, if you are planning to install a new electrical circuit, be sure to obtain the necessary permits from your local building department. Permits are required to ensure that the work is done in accordance with the NEC and local electrical codes. 29thly, when selecting a location for a splice box, consider the environmental conditions. Avoid locations that are exposed to excessive moisture, heat, or corrosive chemicals. 30thly, make sure you understand the difference between grounded and ungrounded conductors. The grounded conductor, also known as the neutral, is typically white or grey. The ungrounded conductors, also known as the hot wires, are typically black, red, or blue. Never connect a grounded conductor to an ungrounded conductor. 31st, the size of the conductors used for a particular circuit must be appropriate for the amount of current that the circuit will carry. The NEC specifies the ampacity of different sizes of conductors. 32nd, when making splices in a multi-wire branch circuit, be sure to maintain the continuity of the grounded conductor. A broken grounded conductor can cause voltage imbalances and damage to electrical equipment. 33rd, if you are working on a circuit that is protected by an arc fault circuit interrupter or FSI, be aware that FSIs are designed to detect arc faults, which are a common cause of electrical fires. FSIs can trip even if there is no ground fault. 34th, be sure to properly label all of your electrical panels and circuits. This will help to prevent confusion and ensure that the correct circuits are energized when performing maintenance or repairs. 35th, it's important to choose the correct type of enclosure for the application. Some enclosures are designed for indoor use only, while others are designed for outdoor use. Make sure the enclosure is rated for the environment in which it will be installed. 36th, always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. 37th, when working with electrical systems, it's important to have a good understanding of basic electrical principles. This includes Ohm's law, which describes the relationship between voltage, current, and resistance. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. 38th, another important electrical concept is power, which is the rate at which electrical energy is used. Power is measured in watts, and it is equal to voltage times current, or watts equals volts times amps. 39th, energy is typically measured in kilowatt hours, which is the amount of energy used by a 1000 watt device for 1 hour. 40th, when calculating the load on an electrical circuit, be sure to consider all of the devices that will be connected to the circuit. This includes lights, appliances, and other electrical equipment. 41st, the NEC specifies the maximum load that can be connected to a particular circuit. This is typically expressed as a percentage of the circuit's ampacity. 42nd, when running conductors through conduit, be sure to use a lubricant to reduce friction. This will make it easier to pull the wires through the conduit and prevent damage to the insulation. 43rd, avoid using metal fish tape on energized circuits. Metal fish tape can conduct electricity and create a shock hazard. Use a non-conductive fish tape instead. 44th, if you are working on a circuit that is controlled by dimmer switch, be sure to use dimmer-compatible light bulbs. Using non-dimmer compatible bulbs can damage the dimmer switch and create a fire hazard. 45th, if you are installing recessed lighting, be sure to use recessed lighting fixtures that are IC rated. IC rated fixtures that are designed to be installed in direct contact with insulation. 46th, when installing smoke detectors, be sure to follow the manufacturer's instructions and local building codes. Smoke detectors should be installed on every level of the home and in each sleeping area. 47th, carbon monoxide detectors should also be installed in homes, especially those that have fuel-burning appliances. Carbon monoxide is a colorless, odorless gas that can be deadly. 48th, regularly inspect your electrical cords and plugs for damage. Replace any cords or plugs that are frayed, cracked, or otherwise damaged. 49th, avoid overloading electrical outlets. Overloading outlets can cause the wires to overheat and create a fire hazard. 50th, unplug electrical appliances when they are not in use. This will save energy and reduce the risk of electrical shock or fire. Splice boxes are a vital component of safe electrical systems.